Okay, so our lesson today is on transformations. And we probably won't get through all this in class, so if you have to take a couple days to get through this, as you watch the video, that's okay. I'll let you guys read about the reflection, translation, and rotation. When you're younger, we called them the flip, the slide, and the turn, but now we need to call them by their mathematical terms, the reflection, the translation, and the rotation. So you can look through that. So we're going to get down here to the examples. So the first one says use a reflection in the y-axis to draw the other half of the figure. So first of all, we need to determine what is the y-axis. So here's our y-axis right here. And we really just want to mirror that to the other side. So this is about 1.5 blocks in the middle. So 1.5 blocks in the middle. Let's try that again. And then it goes over 2.5 blocks. And then down here it meets at 0, 0, and it goes over 1 box. So it goes over 1 box. And you have mirrored that in the y-axis. The next one says graph rectangle ABC with the vertices. So let's do that first. The vertices at -5, 2. And 1, 2. And 1, -1. And 5, -5, -1. Okay, so we have our rectangle. Now we want to graph its image after a reflection in the line x equals -1. So here's the line, x equals -1. So we want to reflect it in that line. So from that line, we go right 2 to get to B. So that means we would go left 2 to get to B prime. From the line, we went left 4 to get to A, so we'd go right 4 to get to A prime. And prime just means that it's had one transformation that has happened to it. So this one will go back 2, and this one will go forward 4. And when we draw that in, we have reflected that over the blue line, the x equals -1 line. Okay, this one says graph the figure and its image after a reflection in the x-axis and a reflection in the y-axis. So two things are going to happen. So let's start with our reflection in the x-axis. So here's our x-axis right here. So we want to reflect that. So I'm going to find my points. I have a point there. Looks like it crosses again up here at 8. So when I reflect that upside down, I want it to cross at 8. Oops. I want it to cross at 8. I want it to cross again at 6, -8. And so this is your first transformation. So that was the reflection in the x-axis. Now we need to take our reflection in the y-axis. So this time we're going to reflect here. So that means it's probably going to match up right here. And then that's 1, and so this point that I'm looking at is 1.5 boxes. So I'm going to go back 1.5 boxes. And then we know that another 1.5 boxes, we're down at 8. So that is your reflection in the y-axis. Okay, now this one's going to be difficult for me to do on the iPad, so hopefully you guys will get to see us do this one in class. But what you need to do is you need to take your ruler, and I actually use like the edge of a piece of paper. So I take my edge of paper and I line it up just like this. And then I mark that spot. So I want it at a 90-degree angle right here. And then you're going to take that paper and you're going to scoot it over 90-degree angle here, and you're going to mark that same location on the other side. And you want to continue doing that with all of your points. Oops. With all of your points. So mark it here, mark it there. And remember, you're doing this with paper. Alright, this time we're going to line this one up. So you would line it up here. Line it up there. And mark that. And I'm just eyeballing this, but I would rather you guys pause and get your paper out and try that. So then you're going to line it up here. Then flip it over and mark that. Flip it over, line it up there. And then you can connect your dots. So R prime, Q prime, S prime. Mine doesn't look too bad having not done that with actual paper. But you kind of get the idea. Like I said, hopefully that you get to see that. So there are coordinate rules. Now, I never use the coordinate rules for reflection because a lot of times you could just count and kind of see where it goes. But if you want the coordinate rules, here they are. For any coordinate x, y to reflect in the x-axis, you're just changing the y to a negative or the opposite of. To reflect in the x, you're doing this, or to reflect in the y-axis, you're doing the same thing to the x. And then sometimes they ask you to reflect in the x equals or y equals x line. In that case, the x and the y just switch places. This might actually be one that you'll want to memorize. The other two I think you can figure out. Okay, so you guys are going to go ahead and just pause for a second, and you're going to try these on your own, and then you can turn this back on, and you can check and make sure that you've done these correctly. Okay, after you've checked those to make sure that you've gotten the right answer, then you can go ahead and move on to our translation examples. Okay, translation is, remember, what we used to call a slide. So it says figure A, B, C, D, and I hope you figured this out on your example that you need to draw an X and Y axis. We're actually going to draw our axis a little bit lower on this one. And then we'll put this one kind of in the middle. Okay, this is figure ABC has vertices at A being at -2, 3. B at 1, 5, and C at 0, 2. So we have a triangle. Sketch ABC and draw its image after the translation of x minus 3 and y plus 2. So this means that you take the first coordinate and you subtract 3 from the x value and you add 2 to the y value. So -2 minus 3 is -5, and 3 plus 2 is 5. So B prime, 1 minus 2, or 1 minus 3 is -2, 5 plus 2 is 7, and C prime, 0 minus 3 is -3, and 2 plus 2 is 4. So this should just move it down 3 and right 2. So let's graph those points and see. So it goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. How about I said that backwards? How about it goes left 3 and up 2? That would make more sense anyway. Okay, so -2, 7. So that was A prime. That was B prime. And then C prime is at negative 3, 4. And like I said, I went the wrong direction when I said it the first time. So this should be left 3 and up 2. Should be the exact same image, just moved to a new position. So sometimes they just give us the words and they want us to write this. So we use the coordinate notation. By the way, this is coordinate notation right here. Use the coordinate notation to describe the translation. Right 7, down 3. So X is going to go right, that's in the positive direction, and Y is going to go down, so that's the negative direction. So there's your coordinate notation. If 2, 0 translates to 4, 1, and then 3, 4 would translate to what? So we have to figure out, to get from 2 to 4, X had to add 2, and to get from 0 to 1, Y had to add 1. So there's our function notation. So let's apply this now to 3, 4. So 3 is going to add 2, so that's 5. 4 is going to add 1, and that's 5. That leaves us our new coordinate. Okay, so once again, I want you to pause the video and I want you to try these. And then when you are ready, come back and check your answers. Okay, so if you've checked your answers and you have those right, then go ahead and move on to our rotation examples. Now, rotation examples, you are going to want to memorize the coordinate notation for this because that's going to be the easiest way to remember how to do these is to memorize them. And the more you do, the more it starts to kind of make sense on how this works. Okay, by the way, rotation is usually counterclockwise. Counterclockwise is abbreviated CCW. That would be counterclockwise. If they want you to go clockwise, they would use CW. So counterclockwise goes in reverse to what the clock does. Clockwise goes in the same direction, at least with the clock does. Okay, so let's look at this example. It says the coordinate, or find the coordinate of triangle A double prime, B double prime, C double prime. That means we're going to do two things to it before we're finished. After a reflection in the x-axis and then a rotation of 180 degrees about the origin. So all of our rotations that we learned about are always about 0, 0. Okay, so we need to start by graphing this. So A is at negative 3, 1. B is at negative 2, 3. And C is at negative 1, 0. So the first thing that has to happen is that we have to have a reflection in the x-axis. So here's the x-axis right here. And we want to reflect that. So C stays the same, that becomes C prime. A flips down. B is up 3, so we go down 3. So there's the second transformation. And then it says, so our new coordinates for A prime are at negative 3, negative 1. B prime, they are at negative 2, negative 3. And C prime, they are still at negative 1, 0, because that doesn't move when you reflect it, because it's on the line of reflection. Then it says, rotate about the origin 180 degrees. So let's look right here. 180 degrees says that we need to take the negative x and the negative y. The negative x and the negative y. So our second transformation, so double prime, would be a negative x so that's positive 3, and a negative y, which makes a positive 1. B double prime, we're going to have a negative x, so that's a positive 2, and a negative y, which is a positive 3. And then we're going to have C double prime, which is going to be a positive 1, 0. So let's graph this one, and it should rotate about the origin, and actually when you go 180 degrees clockwise or counterclockwise doesn't matter. So this goes to 3, 1. That becomes A double prime, and then 2, 3 becomes B double prime, and then 1, 0 becomes C double prime. And we have taken this figure and rotated it counterclockwise 180 degrees. Okay, so the figure to the right, we want a 90 degrees counterclockwise rotation of MG. So here is MG. 90 degrees, so counterclockwise, so we're going this way, about J. So J is our center. So where would this line up if we rotated it 90 degrees? It would line up right there. So it would end up on line DK. Okay, so this next one says 180 degrees HI going clockwise about J. So here would be 90, here would be 180. So KG. That's a terrible G. Let's try it again. There we go. Okay, and the last one is a 90 degree counterclockwise, so we're still going counter, of triangle HGC. So this triangle right here, when it rotates 90 degrees, it would be right here. And it listed the H first, so when you rotated it, the H would be right there. So let's list that number, or let's list that letter first. So G, E, D. Okay, so once again, I want you to pause, see how you do with this, and then check your answer. Okay, once you've checked your answer and you're good, then let's go ahead and move on to the dilations examples. Okay, so the first types of dilations that we're going to do are dilations from the origin, from the center. So a dilation means that it's multiplied by this factor. So let's start with this first one. A is at 1, 1. B is at 2, negative 1. And C is at negative 2, 0. To dilate this by a factor of 2, we take both terms times 2. So A prime is at 2, 2. B prime is at 4, negative 2. And C prime is at negative 4, 0. So 2, 2, 4, negative 2, and negative 4, 0. If you draw that in, it should look exactly like the original, just bigger. And it's gotten bigger by a factor of 2 from the point of origin. Okay, so this one, and they give us the coordinates. So A prime, this one says we want half of x and half of y. Okay, so half of x is 3, and half of y is negative 2. For B prime, half of x is 1, half of y is negative 4. So let's see. Let's pick color this one on there. We'll do green. So at 3, negative 2, and at 1, negative 4. So notice that when you have a fraction, it's called a reduction. And when you have a whole number or a number greater than 0 or greater than 1, then you have an enlargement. So something less than 1 is a reduction. Something greater than 1 is an enlargement. Okay, once again, I want you to try this one. The scale factor is by 1/4. So this is going to be a reduction. Pause your video and see if you can do this. Okay, once you've checked your answer, then we'll go on to the very last section, which is dilations with a center that is not at the origin. So we have a little explanation over here. So in order to do a dilation where the center is not at the origin, then you have to use the slope. You have to use rise over run. And so this one says, if you count your slope, and so I'm just going to use a highlighter here and show my slope. You can see that my slope goes up 2 and over 5. So that's where those numbers came from. And then if we want our scale factor, if we want it to double a dilation of 2, and we're going to center it around this point right here. So we're going to take the coordinate and we need to go by 2. We need to go up 4 because 2 times 2 is 4. And we need to go over 10 because 2 times 5 is 10. So we're going to go up 4 over 5, 6, 7, 8, 9, 10. And this would be h prime right up here. Okay, so on the next one, find your slope first. Let's rise over run. And then this time by 1/3. So this time it's going to be a reduction. So what's your rise over run? Alright, and then when you're done, come back and check and see if you got the right answer. Okay, hopefully you got that right. That should conclude our notes for transformations. You do have a worksheet that you can complete with this, and you also have your GeoGebra activity that's due inside of Google Classroom on Friday. You can work on either one of those.